Hi, I'm Sean Gannon, and this is minutemath, and today we're going to learn about adding and subtracting polynomials, and we're going to simplify each expression. So if I was given this expression, 3v to the fifth plus 8v to the third minus 10v squared minus negative 12v to the fifth plus 4v to the third plus 14v squared. Okay? Well, what do I do from here? Well, I need to first I like to simplify within each parentheses. Nothing to simplify. So now I'm going to make all my negatives be adding up positives. So we have 3v to the fifth plus 8v to the third plus a negative 10v squared. Sorry, added a negative. Then I'm going to distribute this subtraction sign right here to all parts. So negative times a negative 12v to the fifth is a positive 12v to the fifth. All right, positive 12v to the fifth power, not second power, fifth power. Distribute that here. We have adding a negative 4v to the third. And then the last one, adding a negative 14v squared. So now what I'm going to do is put all my like terms together in my highest degrees first. Highest degree I see is the fifth power, so 3v to the fifth, with a dot, shows I brought it down. Next one here is 12v to the fifth, so we have 12v to the fifth as well. I don't see anything else to the fifth power, so I see anything to the fourth power? Nope. C to the third power? Yep, third power I see, 8v to the third, and then adding a negative 4v to the third. Now, do I see anything else with v to the third? No. V squared? Yes, there's two of them. Adding a negative 10v squared here, and this one here, adding a negative 14v squared. So now we have all of our terms brought down. Let's double check. 3v to the fifth is right here, 8v to the third, right there. Negative 10v squared, 12v to the fifth, negative 4v to the third, and negative 14v squared right there. Okay. So now we have everything down. Let's go simplify our like terms, or combine our like terms. 3v to the fifth plus 12v to the fifth is 15v to the fifth. 8v to the third plus a negative 4v to the third is a positive 4. If I can write a 4v to the third. And then lastly here, we have two negatives. Negative 10v squared plus a negative 14v squared is a negative 24v squared. Now I rewrite this as my final answer. To that, have plus and negative, but subtraction. So again, when I solve, I like everything addition, but for the final answer, let's move it back to the subtraction. So we have 15v to the fifth plus 4v to the third minus 24v squared, and there we have it. Our final answer. So let's recap. We're given two sets in parentheses here, 3v to the fifth plus 8v to the third minus 10v squared, and then subtract the other one, negative 12v to the fifth plus 4v to the third plus 14v squared. I distributed the subtraction sign across and made everything adding a negative. Then from there, I rearranged my like terms first. The highest degrees are like terms together, highest degree first. So I had the fifth powers, and the third powers, and the second powers. I used my dot method and double checked it and made sure I brought everything down. Then from there, I combined my like terms, giving me 15v to the fifth, 4v to the third, and negative 24v squared. Well, when I rewrote this to be my final answer, the adding a negative made just subtraction because I thought it looks nicer. So now my final answer is just 15v to the fifth plus 4v to the third minus 24v squared.